Okay, so let's solve today's Leetcode challenge, sliding puzzle. So in the questions given 2, 3 chessboard where there are 5 tiles labeled from 1 to 5 and an empty square represented by a 0. A move consists of choosing 0 and 4 directionally adjacent numbers and swapping it. The states of board is solved if and only if the board is 1, 2, 3, 4, 5, 0. Given the puzzle board, return the least number of moves required so that the state of the board is solved. If it is impossible, we have to return -1. So this is the first example given. Just shift these two adjacent and get it. For the second one, we would shift this once and no, here it's not possible because 0 is already at the required position and these two are not. So it's impossible to convert it to the resulting string. Here it is possible by moving blank to here and here. These are the constraints. Very less constraints. Right? So I think brute force approach is also one. So let's start understanding what that problem is asking. So these were the given parameters. Only 0 to 6 numbers would be present in the grid. We have to find the minimum number of shifts from 0 to get this final 2x3 game. So the first method which comes to our mind is constraint is given that around 0 we can move in 4 directions adjacent to it and not more than that. So we will try every possible combination of shifting 0 to possible adjacent positions and see whether we get our final grid as answer. So taking the example for driving, here we have our 0 initially given to us. We can shift it towards the left adjacent window, upside or right. At the bottom we have nothing so we cannot shift them. These are the possible cases. Out of them, this is the resultant which we require. So we found out at the first move itself. Answer would be 1 and 2. So for ease of implementing the solution, we convert this 2 into 3 grid into a string so that we could easily map the moves in a map and then directly take it for the DFS approach. So as we can see here, convert this into a singular, we would need this 3 divided by 3 will give us 2. So if 0 is present in this position, it can move in 1, 3 or 5. It can move to 1, 3 or 5. So we will map it like this. 1, 3 or 5 in this singular string. So map of indices of 0 to VDD to places it can shift 2 in 1D and then use them to code up BFS properly. So we have to maintain a visit set list to not get combinations already checked. Because like if we go from here to again shifting these two. Like the 0 can again go to the left side from here or upside. So if we take the left side again, we will reach here again. 1, 2, 3, 4, 0, 5. So this would be an infinite loop then. We would never reach this end if we just continue to shift these two side by side. Our EFS DFS option would never end. So that's why we need this visit set. Time complexity, we can infer that all the elements here would be unique. So any six of the elements can be present in the first position, any five in the second, any four in the third, three in the fourth, two in the fifth, and this is expected. Just m cross n. These many combinations are possible. Out of them, we would check that if that combination is present in the visited array set or not. So that would take an even more n cross n time complexity to build that string, store it in the visited set. So total time complexity would be n cross n factorial into n cross n, as n cross n factorial would be 720 and n cross n again would be 6. So this is not huge. That's why this time complexity would clear all the test cases. So now let's write the code for this problem and build a map here. First, I have 1 and 3 positions. For 1, I have 0, 2, 1 and 5. For 3, I would have 0 and 4. 1, 3, 5. The last one, 2 and 4. So these are the positions our 0 can move into according to the constraints given in the question. Now let's create a string out of this for ease of calculation. This is list comprehension in Python. Text storing the index where 0 occurs in the string, the board string, and length 0. First, the length would be 0, and as we make moves, it would increase 4 and length moves. Let's initialize our visit set with the given string. While queue is not empty, I will just take out whatever I have inserted. Now checking if B is equals to our answer, which is 1, 2, 3, 4, 5, 0. If it is, I will just return the length. Next, I would convert it list a string so that I can swap the zero with the possible positions from that. I would take out all the here j means every element in the list. Shift ij in that means UDF instead convert it again to a string to store it again in the map if it is uh, in the set if it is not present, and as well as append in the queue. Now we will enter the next line queue. That's why we have included length plus 1 as the next length value. If we will get an answer, we will return it from here, and if after queue becomes empty and we didn't reach this condition, that means not possible to generate it. The resulting board, we will just return -1. Now let's run this. Okay, comma. Okay, I forgot to add comma. Now I put it. Okay, it's passing on the test cases. Let's run the program. Okay, so today's Leetcode challenge is done. Let's meet tomorrow. Bye bye.